Hello everyone. Hello my friend. Here today we will continue on these questions, and for this question is about the bipolar transistor, right? Bipolar transistor. First of all, we shall know some basic background knowledge. For the BGT, it can be divided to two types. One is NPN, and the other is PNP. Okay, NPN look like this. PNP look like this. Okay, yeah. You can get the type from the direction of this arrow. If the arrow is pointing from P to N, okay, it always pointing from P to N. So this one is NPN, and this one is PNP. Okay, and there should be three zone of the opposition for the BGT. The first one is cutoff, which means VBE is less than 0 and the VBC less than 0. Please pay attention. All our examples is using the NPN transistor. Okay. Second one is a saturation zone, which is VBE bigger than the VT and the VBC bigger than the VT. So both the diode, basically, the bipolar transistor is made of two back-to-back diode. Okay, if the two diodes are both conducted, so it is a saturation zone. So basically, the BGT is working as a pure wire. The third one is active. This one is what we want. Okay, is desired. So it means the VBE should be, this diode should be forward biased. So it should be greater than VT. And the VBC should be reverse biased. So this is the active region. And don't forget these three working operation regions. And we can use a diagram to show it. The x-axis is VCE, and this one, the vertical axis is IC. So it's basically, if it is an ideal bipolar transistor, it should be like this. So the value of IC is only related to the value of VBE. Okay, yeah. And currently, our bipolar transistor is not an ideal one. So it has some slope. Yeah. So if we make it backwards, it will have an intersection with the x-axis. This one is VA. We call it early voltage. Early voltage. Yeah. It comes from, when we increasing the voltage, the depletion region between base and the collector will be bigger and bigger, so it will cause some effect. Yeah, that's a basic idea. You don't need to know. Okay, this is a VA. So the existing VA will cause an additional RO, which is VA divided by IC. So theoretically, VA should be infinite. So RO should be infinite. But in practical environment, both these two values are not infinite. Okay. So this is the first diagram. And the second diagram is a AC equivalent small signal equivalent circuit for the BGT. Okay. So we can see it like this. This is RO, this is RC, this is VO. Okay, at this side it's base, this side is emitter, and here is collector. All right, so that's the basic idea. If the circuit is an ideal circuit, the bipolar transistor, so the RO should be removed because RO is infinite. However, to this question, we should have an RO because the VA is not infinite. All right. Okay, let's move forward. For the first question, it is asking us to use a diagram. We can use this diagram. Explain how early effect influence the output resistance. Okay, so theoretically, the output resistance just equal to the RC. However, in the practical bipolar transistor with the value of VA not infinite, the the RO is RC paralleled with RO. Okay, yeah, and this question is asking us to get the voltage gain. All right, okay. Now we will use two scenarios. The first one we can say without VA. Okay, so no VA, no RO. So our voltage gain for the bipolar transistor will be this one, GM times RC. All right, yeah, GM times RC. So what is GM? GM means transconductor. So conductor, yeah, we know resistor, which is V voltage divided by I. So the conductor just reverse. So I divided by V. This is conductor. So transconductor means the I is in a place, the V is in another place. So it is called transconductor. Yeah. So GM here means IC divided by VT. Okay. Yeah. So that's a transconductor. All right. And this is the voltage gain without VA. If V is VA, so the AV means minus GM RC parallel the RO. Okay, yeah, that's the difference between the voltage gain with or without VA. All right, that's the solution for the first question. Okay, so for the second question, it's asking us to calculate the output resistance RO. All right, it's quite straightforward because we know the definition for RO, which is VA divided by IC. VA is 80. I know it's minus VT. We use the absolute value of VA, which is 80 volts. And the I collector current is 0.2 milliampere. So the final value for the RO will be 400 kilo ohm. All right. And the following thing is quite straightforward. So the totally output resistance is RO parallel with RC, which is, okay, 400K at 10K and 400K times 10K. So the answer is 9.76 kilo ohm. Kilo ohm. Okay, this is 9. Oh, sorry. Yeah, this is 9. And now we can get this RO for the output resistance for the figure 2.1. And for the figure 2.2, it's just add another parallel resistor, which is RL. So the output resistance for the figure 2.2 will be the RO parallel for the RL, which is 9.76 K parallel to 5K. The answer is 3.31 kilo ohm. Okay, so the values, final values or results for this question, I think it's easy, it's straightforward. But please remember the AC small signal equivalent circuit and this diagram. Yeah, I think this question can make us get a better learn of the basic theories for the bipolar transistor. Thank you everyone. Thank you very much. Be safe, be happy. Bye bye.